Okay, let's go for table 1.16. So 1.16 shows the tables of most common pitch diameters of these IP. Remember a while ago we talked about table 1.15, that's what DP minimum. So if you go for the DP minimum there, it means you not let the small pulley to be less than that anyway. Otherwise you don't believe it. You don't cause experiencing the slippage at the driving pulley anyway. So therefore this table show you the pulley that what available most likely anyway. So for instance, like see that the DSRP that what available is going to be starting from 25, jump to 28, 31, 35, things like that, and up to 2,500 millimeters anyway. And then let's see the force on the V belt is going to be exactly the same that what we have got there, but we have e to the power of mu time alpha or sine phi over 2 because it's right based on the figure. We're going to have a mu prime as a parameters there because it's why it's going to be touching on the side of the V belt anyway. So therefore the friction is going to be induced at both sides of the belt itself. Okay, and then let's go for the open drive. So therefore the open drive can the equation gonna be modified, and if we include the centrifugal force it's gonna be look like that, and then F sub C is gonna be centrifugal force, can we make some kind of calculation look like that too. And then see that what I mentioned earlier, the V belt can be applied as much as possible for the number of belts there. And then okay, let's go for another one that what we've got there is gonna be uh, in terms of okay, for the transit power, okay, for the multiple rebuild drive anyway, that what we've got there, see it's gonna be number of belt. It's gonna be very similar thing that what we got there from the number of belts there. So you times Z's number of belt, it's gonna look like that. And the pitch, okay, belt length is gonna be L sub P here. So L sub P gonna be determined from the 2C is the center distance. Okay, pitch means this is going to be the length of the belt in terms of accordingly to the things that what we've got there in terms of the pitch. Anyway, it's going to be reference on that, and then I'm going to talk about later in the table of content, and the center distance can be able to be determined from this the capital C equal to P plus the square root of P squared minus Q, things like that. Okay, either P and Q can be determined from the equation there, and then it's recommended to be the C max and Z min, things like that, based on this equation. Okay, so if you don't believe this kind of recommendation, it's going to cause slippage anyway, or the optimum design gonna be cannot be obtained anyway. So the design of rebuild gonna be considered as the one by one like that. Number one, D sub P. First thing first, you got to determine the D sub P. Okay, that's what got to be not less than the P sub P minimum. Okay, that's what I mentioned earlier. And then you got to determine on the number, the characteristics on this kind of table for the collected power. You just open up for this kind of table, and then you just use a small pulley speed, things like that, and then you just may pick up the characteristics of the belt. For instance, like see if the consideration is going to be around there, you're going to take on the B, the VB belt, VV belt, okay, pulley there. Okay, we got a small size and a bigger size there, respectively. Typically, we're gonna, if you come close to the small side, you may go for the small side. If you go for this bigger side, if the determination is close to there anyway. Okay, so the number of belts can be able to determine based on this equation. W sub P transmitted power, N sub S is service factor. This means from table 1.17. N sub A is going to out of contact. This means from table 1.18. And N1 is going to be the belt length collection factor. We got it to mean from table 1.19 to 35, and the P sub R, okay, we're going to determine from table 1.19 to 1.25. Okay, and then let's go one by one then. For the table 1.17, we have a driving purpose and the prime mover. Okay, it's exactly the same as what we mentioned before, but the working out gonna be determined in three shifts anyway. Okay, one is less than 10, second is gonna be 10 to 16, and then greater than 16 respectively. And the definition is going to be in terms of light duty, moderate duty, and heavy duty respectively. Okay, so therefore, this kind of thing is going to be in the kind of sense that what we've got there. Okay, for the extra duty, also. Okay, it's going to be a misclassification under the vibration and the behavior of the machines, things like that too. Okay, so this is 1.17 and 1.18. Of course, you're going to do the N sub A, the arc of contact, by using the D sub P, or not D small sub P, small d sub P over C, things like that. Okay, and then therefore another one F sub I, you're gonna determine from this kind of equation by use what determine the term of K1 and K2 and the number of belts, things like that. Okay, so therefore the things can be able to determine from K1 and K2. Okay, from the table 1.26 and 27 respectively. Okay, so now let's go for one by one then. Okay, we gonna have a table 1.19. Okay, 1.19 is gonna go for the belt Y. Okay, so if you make a selection of the YV belt, okay, you're gonna go for 19. Okay, if you just gonna go for the Z belt, you're gonna go for 120. If you're gonna go for the A belt, things like that, you're gonna go for 121. So therefore, it's gonna be characteristic the same thing then. Let's go for the Y one first. So the Y1 is gonna refer to the pitch belt length of 319. This is gonna be characterized based on the reference of the L sub P of the Y. Okay, but it's different for the Y L sub P. Okay, for the Z belt. Okay, Z belt is going to be L sub P is 824. Okay, that's a reference. And then you will figure out for the A belt, it's going to reference to the L sub P 1732 respectively. So each belt going to be different from each L sub P anyway. They can characterized by each of them respectively. Okay. So let's see for the things that what we've got there, we're gonna use D sub P to open up for the P sub R here. D sub P and the small puller speed, okay, and then you can be able to determine P sub R respectively. And another one, N1, okay, you can determine from the L sub P there, okay, so therefore you got there, okay, based on this, it's gonna be L sub P, okay, you get start from L sub P is 824 as a reference, and sub 1 equal to 1 then. If you use rather than L sub P rather than this, it's gonna be some kind of relationship based on the N sub 1 respectively, okay, based on this table. So before you're gonna go for L sub P, you're gonna go for L sub I, or pitch belt length. So it's mean L sub P determined from L sub I, initial one, plus in every 22 millimeters, things like that. So therefore, the typically L sub I is going to get start from this and plus in every 22 millimeters. That's what we've got there. Okay, so this is the same, but the characteristics is going to be different. For the A size, for instance, the A size also N1 kind of reference to 1732 for the L sub P, and then L sub P determined from L sub I of this kind of thing in every 30 millimeters and things like that. Okay, so therefore this is 1.22 is going to be this the Y, the B size. Okay, and then for the B size for the N1, okay, and L sub P respectively, And then for the C size, things like that, C belt, okay. And then for 24 for the B belt, and then for the E belt, going to 25 respectively. Okay, and then and then 1.26 is going to be the K1 term there. K1 is going to be working condition. It's going to be based on the light duty, moderate, heavy duty respectively. And then K is up to based on the constants parameters based on the belt itself. For that, the Y belt, you're going to use 0.049, that's things like that. Okay, so this is the things that what we have got there. Okay, and then uh, we're gonna go for the design. For example, okay, example 1.3 is called here an open drive V-belt transmission comprises of a normal torque 4 kilowatts AC electrical motor driving pulley at a speed of 1,450 RPM. The power is transmitted through the V-belt and driven pulley, which is directly connected to the drive of elevator at a speed of 815 RPM. Given that the elevator is operated at 12 hours a day, this means the standard size and the V-belt is current term need for this transmission. Okay? So based on the driven apparatus, based on the table there, 1.17, the elevator can classify as a heavy duty. And the prime mover, that what they said in here is going to be normal torque, okay, 4 kilowatts and AC motor. Okay, and the working hour is going to be 10 to 16 hours. So this is why it's going to be 12 hours, things like that. Okay, so therefore, okay, the service factor is going to be determined from table 1.17. It's going to be N sub S. It's going to be 1.3. So therefore, we find the V sub P. Okay, V sub P time the service factor, we got the collective power there, and the small pulley is given by the problem set. You use these two terms to find out in figure 1.8. Okay, so it come close. Okay, come close to the A size anyway. So that's why we go for the size of A. We belt things like that with a DP recommend to be 80 to 100 millimeter. And then we got to check with the table 1.15. Okay, the SRP for the A belt is going to be 80 millimeters. So therefore, no doubt about it, its range is going to be 80 up to 300, up to 100. So therefore, we, based on the table 1.16, the available pulley is going to be make a selection of 90. That's the answer. Okay, and then the speed ratio. Okay, if we select on that already, is N1 over N2 is going to be 1.75. So therefore, it's going to be determined for the D sub P. Okay, we have these small sub P's already, so therefore we got the capital B D sub P. That can be the answer. And therefore, the C max and C min are automatically determined as this kind of equation. So therefore, it's gonna be from C max and C min anyway. So therefore, I make a selection as a trial and error, things like that. So therefore, I got the L sub P is gonna be in terms of 1,100 something. So therefore, I go for table to 1.21, okay, 1.21, okay. I got L sub P equal to L sub I plus 30. So therefore, based on table 1.21, I select L sub I is 1,200. So therefore, plus in every 30. So therefore, the pitch there is going to be 1,230. So therefore, I find the C term there. Okay, I find P and Q respectively. I plug it back to find the C term. So the C that was recommended to be is going to be 417. That's the answer. We got to manipulate this kind of center distance for design. So therefore, based on table 1.18, we just find the N sub A. Okay, 1.21, we got N1. Okay, is the 0.91, and table 4.21, the sub P is 90, and M sub of 1.75, and N is equal to this. P sub R is equal to 1.46. We plug everything down in the number of belts. We got the numbers of belts is 3.9 something. So therefore, we gonna round up to be 4. Okay, that's the kind of numbers of belts. And then we find alpha 1 and alpha 1 and then and then we got the force of that, and then we find the K1 and K2. We plug it in, we got the answer of F1 respectively. Okay, so this is the answer. And then we can summarize all the things for the design of this, okay, particular in each manner, anyway. And then for the tooth belt, that what we've got here is going to be is pretty much look like the things that what we have a sprocket and chain design. We're going to talk about in the next chapters anyway. Okay, then what we've got there is a timing light anyway. Okay, and then okay, I think it's gonna be done for the things that what we've got here already. So I also got so many problem set. Okay, number one is very good design things like that, and number two, okay, for the flat belt, whatever. Number three, also the fat belt. Okay, number four, fat belt. Number five, the V belt. Okay, and six, seven, eight. Okay, it's gonna V belt respectively. Okay, please. Okay, try it out myself. Okay, you saw the problem with the problem set there. Okay, I would like to end this for the chapter one. Okay, it's gonna be on the belt transmission system design anyway. Okay, that's it for chapter 8 anyway. Okay, all right.